Hi everyone, welcome to session 4 of our System Architectural Foundation course. Let's quickly recap on what we've studied so far and what is it that we are going to cover in today's session. So, till now, we understand why, as a Scrum Master or a technical project manager, we need to know the system architecture. One common word which I've been using throughout the series is you are no longer just the facilitator or a collaborator. You are moving towards being a strategic enabler. And how you can be a strategic enabler until and unless you understand the engineering terms, you understand what system architecture or design consists of, because these are the things which help you understand the risk, dependencies, time scale of the project. Then we went ahead and understood what are the things which drives system architecture. It's your functional, non-functional requirement, or in short your quality attributes. It could be scalability, reliability, tolerance, and many other things. Then we went ahead and we understood, okay, when we talk about system architecture, what are the building blocks? Similar to when we talk about Scrum, right? So when we talk about Scrum, you have things like daily stand up, you have roles like product owner, development team, you've got retrospective. So similarly, when we talk about system architecture, there would be various building blocks which would be making these system architecture and helping us attain the good attributes or a quality of a system architecture. So we learned about things like messaging, message broker, API gateway, etc. Now, today we are going to study about architectural patterns and style. So, what do you mean by software architecture pattern? They are kind of your blueprints for structuring your software system, and also they help you understand how these various components which we talked about, right? Okay, you've got front end, you've got back end, you've got various building blocks, how they are going to coordinate or interact with each other to attain what is given in the requirement. And it's a reusable solution for a common design problem. So this is a very important line for us to understand. For example, you are joining an organization and they are going to build a e-commerce application. Now you know there are already so many e-commerce application available in the market, so you can go ahead and first understand about the key functionality, and also now you have to go one step further and look at their engineering block. Understand, okay, how they went from one stage to another stage, how they are managing, went from managing a small transaction to a large transaction, right? So you can always reuse those common design patterns in your organization, and they help in promoting, yes, consistency, maintainability. These are the things which your blueprint helps us to solve. Okay, so we'll study about three architecture pattern. One, your multi-tier architecture pattern, which is also called as n tier. Here you will have studied about three-tier architecture, two-tier architecture, and you would have seen, you would have evolved in an organization from using two-tier to three-tier to n-tier, etc. Then most common one, which is your microservice architecture pattern, and finally event-driven architecture pattern. We have to understand that when does a new concept or pattern comes, right? The previous pattern may be having some disadvantage, which leads us to go to the next kind of architecture pattern. So any new thing which gets introduced helps us resolve the problem which we were facing in the previous patterns. Okay, so multi-tier architecture. So let's talk about a three-tier architecture, which you would have studied and which you can see also, like while working in an application. You have something called as a presentation layer. This is your client, this is your web app, this is your mobile app, that's your presentation layer, right? Then whatever you are doing on the front end, there would be a business logic, right? So where is that business logic present? That's present in your application layer. And finally, there would be data retrieval, save, etc. So third layer would come, which would come, would be your database layer. Now, looking at the diagram, you yourself can see that this application layer has all the business logic, right? So it is, and we always talk about one of the good quality attribute of your system is scalability, availability, or organization scalability. For example, if we decide to add more developers, now as the application layer is single, it's acting like a monolithic structure, you won't be able to scale your teams, right? You won't be able to go into that multiple sprint teams, etc. There would be a lot of dependencies, a lot of conflict, so everything would get delayed, right? If somebody wants to merge something to this application layer, make a change, there has to be a coordination between so many individuals, right? So, an example like a e-commerce application. So, if we talk about e-commerce application, there what would be your three tiers? First would be presentation layer, wherein it's kind of web page, right, where you are able to browse the product, add items to the cart, complete the purchase. It's all about your buttons, layout, forms, navigation bar. So these are your presentation layer. But for everything on the front end, okay, you're purchasing an item, so there has to be a layer which does all the logical part, right? Or you've integrated your application with a third party payment system, right? So all that integration, interaction, etc. takes place through your application tier. And finally, database for your I'm sorry, database for storing or retrieving of the data, order history, inventory, right? So this is your example of e-commerce application in these three layers. Now, as I told you, right, when we move from one pattern to another pattern, the next pattern would be solving the problem of the previous pattern. So what was the problem on the in the sorry previous pattern? This layer, this business layer, right, where you had all the logic here, right? So this was preventing you to scale, and scalability is one of the quality attribute of the application. See, it's not that this architecture pattern is not useful. It is useful when your user base is small, when your application is small, right? That time going for three-tier architecture is a good approach, right? When you know your application layer is not going to evolve so much. In fact, I missed this one, two-tier one. What do we mean by two-tier? So in that case, what would happen? Your presentation and application layer would be kind of one tier, and then you'll have your database, right? So to start with, this is a good approach, having a two-tier or three-tier architecture. But as your system expands, your application expands, you have to think about other things, right? So what is microservice architecture doing? Okay, let me just erase this. Okay. Okay, no worries. I'm just not able to figure out. Okay, we'll leave it as it is. That annotation option, I think I've got it. Okay, okay, hold on. Let me just erase all this to, yeah. So quick recap. So we are studying about the architecture pattern. First, we understood the multi-tier. In that, we studied an example of a three-tier and a two-tier architecture. Now, we saw what was the disadvantage of your three-tier architecture, where all the business logic was in one layer, right? So we go ahead and split those application layer into a logical tier, and they are loosely coupled. So when we had studied about building blocks, API gateway, you would have seen that every services was solving one purpose, right? And they were independent of each other. Like, okay, you go ahead and let's you go ahead and divide your application layer into multiple microservice. But if there is a dependency, like you went ahead and did the division from a monolithic to a microservice architecture, but if they are tightly coupled, then again you're not solving the purpose, right? So each microservice should be divided in a such a way that it is solving one single purpose, and it could be owned by a separate team. So now for every microservice in a simple language, you should be able to do the development on those microservices in one sprint team. So for one sprint team for things related to user service, one sprint team for anything related to product service, one sprint team for things related to notification, etc. Right? So how does how dividing it into a collection of loosely coupled services helps? Now you are building and testing is very fast, right? There is a separation of responsibility, okay? And also troubleshooting and adding. Now you, for example, now you want to add a recommendation feature to your application, right? So you can easily add a new feature, spin a new team, and they'll be working on a recommendation system, right? So and whatever changes is being done in one service would should not impact the different service. Yes, there would be a time where there would be a dependency, but we have to ensure that that dependency is less. So this is the example of your, again, e-commerce. So you see, now you understand what do we mean by API gateway, what do you mean by messaging broker. I'm just talking about this layer. See the your application layer. Now it has been divided into multiple microservice, and each microservice has their database, right? So you've separated everything, the services and the database. So these are the best practices. Yes, when you are splitting the database also, you have to ensure that this anything done on this should not impact this. They should also be independent, okay? And there is a single responsibility principle. So now you should, when people are talking about these terms, you should be able to understand, okay, single responsibility principle, what do we mean by that? Okay, it is separated by a business card. So shopping cart has different functionality, discount has different, ordering has different, and each is having their own databases, okay? So from here another patterns arises, which is your event driven architecture. Okay, so what do you mean by event driven architecture? Let's go back here. Okay, for example, if there is a service, okay, let's go to the next one and then we'll do it. Okay, so you've got service one. Okay, so you've got service one and you've got service two, service A and B. If there has to be a communication between these two services, A should know about B, right? Schema, the parameters, etc., right? They are tightly coupled. And as these services increases, see how much they have to know about each other. Okay, and if there is any update, you have to wait for the update. Remember, we discussed about this synchronous and asynchronous communication, right? So if you take an example of synchronous communication, you see this service A has to wait for the response from service B. So what if we, and there would be so many services now when we are moving towards from monolithic to microservice, and we are aiming for single responsibility principle, right? So it's too much for a services to remember about each other, okay? So now we'll go into another pattern, which is your event driven architecture, right? So we studied about two till now, multi-tier. Then we went into your microservice architecture pattern. And third is your event driven architecture. So first let's understand what do we mean by event. Okay, so these could be change in the state or an update. For example, you're adding item to the card. So that's there is a change in the state. And you're in event driven architecture, there are three components involved. One is your event producer, right? So the example which we were talking about in a previous uh, okay, so SA would be your, say, producer, right? That's your event producer, right? This is the one which would be making some changes in the state. There would be some update, and there would be a event consumer, so your service B. What is your event router? Remember we studied about message. broker. Those are your event router, right? So now whatever is being done by event service A, service B won't be waiting, right? It would have just subscribed to this message broker, okay, and whenever there would be an update, it would get a notification. So it's there are two kind of notification: pull and push, right? So in case of pull, you have to constantly check, is there any update, is there any update. In case of a push, you'll get the notification moment there is a change in the state, or there is some update done, right? So now if we have to scale, we can scale this particular service independently, this particular service independently. There's no dependency. Service A should not know about the schema etc of service B, and A will not be waiting for service B to respond or see if whatever has been produced is being consumed by your consumer, right? So here your event router, which is your message broker also, or your event bus etc, this helps in all the surge of traffic, and it also maintains whatever is being produced, right? Maybe if we talk about a banking application, right? So you can say there was a deposit of 1,000, there was a withdraw, there was a credit debit, everything this event router is maintaining for you. Okay, so let's move to the next section. Okay. Yeah. So this is the simple division. So you've got your producer A, B, C1, C2, etc., and then your event broker. So this is the architecture of your event broker. You have something called as a topic, partition, etc. There's a concept of master slave, but we don't have to go into that detail. It's just that now you see between two services. I mean, these are your between your producer and consumer. There's something called as event broker, right? So this helps us to make services decoupled, and which enables us to scale or add any feature independently of each other. This act as a your event broker, act as your router, and if there is a surge in the traffic, consumer won't be impacted because this would be able to take care of it. Okay. And as I told you, this is a push based routing, so it reduces the polling overhead. Like consumer will not be just checking every time, is there any update, is there any update. Moment there is an update, if consumer has subscribed to it, would get the notification. It's similar to your YouTube, right? You don't wait that when would be a new session from career stock, right? You've subscribed to that channel, moment there would be upload of a video, as you are one of the subscribed individual, you subscriber, you'll get the notification, right? A very important thing, you can with this architecture, you're able to audit. Remember I was giving an example of banking system, right? So whenever you're doing any, let me, yep, yeah. So yeah, so this maintains something called as event log. Okay, so log of the event. So if there is a, for example, here one of the service is your fraudulent service, right? Now this service can monitor what's happening here, right? And if it sees that there are some fraudulent activity happening, there was three transaction done from same card, two from one place and third from somewhere other place, or in a very short span a lot of transactions are happening, it can audit this logs and notify the user service. Now user service, what it would do, it would inform the users that we see there is a some fraudulent activity happening on your account, okay, so that user can take the required action. So this is another benefit of having this event router or a event broker which maintains your event log, because you can audit. Otherwise, if we were not able to audit, what would happen? For example, there was some, all these fraudulent transaction would have been done, it would have come to fraudulent service, right? So the detection would have been little late, and you would have made updates to database, etc. So doing the rollback would have become challenging. But here, before the data being sent to the fraudulent service itself is noticing what's happening in the event log. Yeah. So this is what we mean by audit with ease. If you want to know more about event driven architecture, go to the AWS website. They've talked about uh, this in a very simple language, right? Now, from this particular event driven architecture, we can drive to other architecture pattern, which I briefly talked about, which is event sourcing pattern. So wherein ideally what would happen? Let's see. Ideally, we'll have, again, let's go. Service A, which is your producer. Here you have event router, and you have service B, your consumer, and there would be a database, right? So as you're saving all the series of event in the form of event log, if there, you don't have to make do all the transaction in DB, right? Okay, you started with 1,000, then there was withdraw of 100, right? Then there were addition of say 1,000 again, then there was a withdraw of say 900, etc., right? So instead of saving everything in the database here, right, all the details, you're logging all the event here, and at the end you replay and find the current state. Okay. So in this case, if there is a fraud also, you can compensate for that fraud. For example, there was a fraud of 100 rupees, right? So while replaying, you can just add 100 and compensate for the fraud which happened. You don't have to touch the database, right? So this event sourcing pattern, again, from where you are sourcing the event, from the event log, which is maintaining your series of event. Okay, and you just replay that event log, you'll be able to find the current state, and you don't have to save the detail to database. When would you save the detail to the database? At the end. Okay. Yeah, so let's move to further. These are important concept, I know, so you have to listen to it multiple times and then go through the blogs, etc. Another pattern which arises from event driven architecture is your CCOS pattern. This is used to optimize your database, right? So what does CCOS refer to? Command, right? Query responsibility segregation, wherein you are splitting your database into what in terms of query or in terms of command. Command is like, okay, your CRUD operations, right? So in CRUD also, post patch, etc., those are your CRUD operation. Query is your get, right? Read data. Okay, so again, this is the user, you've got service A, service B, and this is your event log, right? So you have now you're not focusing on just optimizing for read through cache, etc., or optimizing for write. You have segregated the DB, you've segregated the responsibility. There would be one database for write and one database for read. But now the question would come, the data has to be consistent, right? There would be a common entity on which the update or read would be happening. Like if there is an addition, you want to ensure that whatever is being added, the read DB has the update, right? So if say count was 5 and with write the count becomes 6, it also should reflect 6. So from where you will get that? Event log again. So service B would have subscribed to this. It would replay whatever is written in event log and then update the read DB. Similarly, write would do it. It would have subscribed. There would be any change. It would make the it would replay the event and do the update. Okay. With example, let's study the same thing with an example. I hope you're following, right? Till here, it's clear, right? That till here we studied, right? This is your event-driven architecture where there are your three entities: producer, consumer, and your event router, message broker, etc. What we've done with CCOS, we've divided the database into command and query responsibility. So this is like you're doing giving a command. This is like you're querying. But these two also have to be updated, right? So how do you attain and how do you ensure that we are able to segregate the responsibility but also ensure your database is consistent? This would subscribe to this. So whenever it would read all the event log and find the current state. Right? Similarly, this would have subscribed, would have subscribed to this. Whatever would happen, read the event log and update this. Okay. We'll study. Simple. Have you seen in Amazon when you go and purchase any product, you get the product description and you also get the rating, right? So let's take that example. Before C course, right? Before, if we simple, you've got your client, you've got API gateway, then you've got your front end service, your web interface, etc. And for a product, you are maintaining the product description, product count, and other data about the product. And all this is being stored in the database. Similarly, when we are talking about review service, it would have the rating for the product, right? Now, if we have to split this into a C course pattern, right? Everything remains same. See, if we don't split, you have to join these two. Like if we have to find, okay, what is the rating for, say, a book, right? So you have to join these table and find the details, etc. Yeah. And there would be a constant read and write. But if we go ahead with the C course thing, we'll create this product search service. And what it would do, now you should be able to understand, right? So the product search service would subscribe to your review service. And similarly, it would subscribe. This is like, okay, you'll get the notification when there is a change. So, okay, there is a change in a review service. It would replay the log, right? And it would update your database. So now this data would always have the updated detail of a product and its review. Okay. So see, it became so easy to add a service through CCORS pattern. Okay. Yeah. So this is it. A quick recap. I know we studied a lot of things today. But go ahead and read about the engineering blogs, etc. I'll show you some of the things I was reading through. If I found a lot of things from the AWS blog, and as I said, now you've got a lot of AI tools available, right? You've got Copilot, you've got Chat GPT, etc. Any term, anything you're not able to understand, just say, "Help me explain this in a layman terms," and you'll be able to get the answer, right? And whatever application you're working on, find out a similar application which has been built by some other organization, read their engineering blog. So it's all about reading and knowing, right? Once you go through the blogs, see, if you've seen some application and then you read about its design, understanding gets very easier, right? So yeah, we studied about three patterns: multi-tier, microservice, event driven, multi-tier, simple, presentation, application, and database layer. We found what was the drawback with this particular architecture. So we had to go to next, which is microservice architecture, wherein we divided your single monolithic application layer into multiple microservices, serves single business capability. You've assigned database per service, etc. Then we studied about event-driven architecture, kind of asynchronous communication which is happening. You've got producer, you've got your router and consumer, and these are the benefit. You can scale your broker, or your router is able to take care of the search in the traffic. So hence scalability, availability, all those things you're able to follow. Even if there is a failure in one service, it won't impact the other services. Your event router would continue to work, right? But here you'll see the bottleneck then would become your event broker, right? From there, we understood about two more patterns, which is your event sourcing and CCORS. Okay. So go ahead, revise these concept. And yes, I was talking about some of the blogs, right? So I was reading from the AWS itself, what are the benefit of event driven architecture. They are your building blocks, right? So you can find out the services also, AWS services, which helps in like what is the event router equivalent service in AWS, right? So which is like your event bridge. How do you subscribe? Like how do you get a notification? So you've got your simple notification service in AWS, etc. So you find a lot of details, right? And other engineering blocks also. You can Stripe, Netflix, Atlassian, etc. They can You can read about their engineering block, right? You've used Jira, right? And now you know the features of Jira. Just pick one feature and study about the design of that feature on the engineering blocks. Cool. Okay, so see you in the next session, and do tell me in the comment how are you finding these series. Are they useful? Anything else you would like me to add? I try to add as much example as I can, but if we need more, I'm happy to bring those changes in the next session. Thank you.